And actually, I think the first thing I want to show you is on the computer. All right. You're all drunk. What happened to you? So one of the biggest problems in statistics is, in general, not understanding what something means that you found. So I don't just mean not understanding what somebody means after they've written a paper and you're like, what the hell are you talking about? I mean the people that did the study. They get some numbers and they don't really know, or they misinterpret what those numbers mean. One of the most common things that happens, and let me show you an article. There was an article a while back that somebody picked up on a little report out of a university. And the university did a study in Britain, in England, about wherever there were more cell phone towers, there were more babies being born. Therefore, they concluded that cell phone towers influences the fertility of women around the area, so causing more babies to be born. Now, it was just plausible enough for people that didn't have the best scientific background to think, all right, maybe that's true. But do you guys see any possible misperceptions there? So I could find it. Mobile phone birth rates. There we go. So this is not the, what's really funny is, I think from my tone you can tell that there's something wrong, obviously. There's something not quite right here. It's not true to say that. What could be, what's another way to explain it?
They're mixing up causation with correlation.
Okay, good. So the main mistake they're making is they saw that these two were related. They saw that in a place that had more cell phone towers, that place would also have more births, and vice versa. So these two things are somehow related. You with me so far? But just because I know two things are related doesn't tell me that either one of them affects the other one. So if I went in and I just put more cell phone towers around somebody's house, I want, we're trying to have a kid. We haven't had a kid yet. Let me just put some cell phone towers up and invite people over. Yeah, I'm over here trying to help them have a baby or something. Right? So, and then you're just hoping that it's going to work. But that's the misinterpretation. The data doesn't tell you that something actually caused something else to happen. If I see a correlation, I see the two things are related. It doesn't tell me which one causes the other one. And in fact, just like in this case, there's something behind both of them. What would cause both birth rates and cell phone tower number to go up?
Population.
Yeah, population. So if you have more people living somewhere, you're going to have more cell phone towers, and you're going to have more babies being born, right? So the easiest thing to do there is to not look at the number of births. What corrects for, like when people say there are more criminals in California than there are in Rhode Island. Well, duh, there's more freaking people, right? So if you just looked at the birth rate instead of the number of births, there would be no correlation. It doesn't make the birth rate go up. You guys semi with me? It's the whole idea. In fact, a big part of Section 1.4 is they tell you something stupid, like I said the other day. And you're like, what did you say stupid? I said that playing basketball makes you taller. Right? Of course, it's wrong, but I did say it the other day. So what you would have to say is, okay, what's the correct conclusion? Or what's another more valid conclusion to come to? Well, tall people tend to play basketball more than shorter people do. Right? Spud Webb always gave me hope. I don't know if that name... Does anybody know Spud Webb? You remember Spud Webb? Yeah. I think it was five, somewhere around in there, and he still could dunk and stuff. And I was like, no, Jeff, not going to happen for you. Okay. But something else you could do. I mean, you can get scientific studies from any journal in almost any field. Any field you think of is eventually going to use statistics somewhere to analyze something. At one point in the semester, after we had talked about a few things, a couple years ago, I showed a video of there's these little magnetic balls. that you can put together, and you can make them in different shapes. And there are these two companies that were at war with each other. So one of them put out this big video showing the statistical analysis about the quality and so forth between the two. It was kind of cool, and they kept referring to all these terminology that we're going to talk about this semester. So if I can find that video again, I'll try to show it to you. But it's good to realize that if you like music, obviously you got the biggies. You got biology. Where's like statistics? Where do you think of it normally being used? Where do you think of statistics normally being used? Sports. I love it. Yeah, sports just is every year they come up with some other statistic. Baseball is hilarious. I don't know how many freaking statistics. The number of times you're on second base when the other guy hit. Come on, just calm down. Sports, big one.
Sociology.
Sociology in what way?
And rate of crime.
How different things might affect crime rates, so forth. I love it. Exactly. The big thing I always think of is testing a new drug, right? If you're going to test a new drug, you desperately need statistics. You need a control group. You need the people getting the drug, the placebo, all this kind of stuff, and you got to see the differences between them all, and you have to give some kind of statistics that hopefully at the end of the semester you'll be able to read something straight from a study and actually know what the hell they're talking about and be able to interpret the conclusion they come up with. It's really kind of cool. So if I just type into Google study, believe it or not, and maybe give it a little bit of a time frame. Actually, I haven't done this in a while. I just wanted to see what would come up. Nut consumption. This is interesting. What's this thing? Nut consumption with total and cause-specific mortality. Okay. This is weird. You guys kind of with me? So what is it? They're trying to see if the amount of nuts, I don't know, walnuts or whatever nuts they used, and how it's going to, will it help you, will it cause the death rate to increase or decrease? Let's see, blah, 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 blah. Let's see, I want to show you some neat stuff. So first off, they tell you the methods. They had 76,464 women and 42,498 men. Cool, cool, cool. And then look at all this. Now, here's the cool stuff. After we get through, and unfortunately, it's not until chapter 7. We're going to completely understand what this whole area here is saying. But look what they're saying here. They're saying that let me see where we're at. Blah, blah, blah. Okay, let me try and interpret this for you. The ratios for death among participants who ate nuts as compared with those who did not. Okay, so stay with me now. I don't know if you guys can even see this over here. But it says 0.93. So if you ate less than once per week, but you had nuts less than once per week, then it would only be 93% of people versus, so 100 people died normally, only 93 of them would die if they would have all eaten the nuts. Kind of with me? So it decreases by that percent. And you can see the more nuts you eat, the further down that goes. Now, the really cool thing is, and I don't want to spend all day on this study that I just found, but I'm sure later they're going to talk about what they controlled for. Right? If you just do this study and you just kind of randomly assign people, you eat a lot of nuts and you don't eat any. But I love them. Too bad. You could randomly just pick people that have a nut allergy that they don't even know about, and that's going to increase the death rate. That's not good. You could pick people who just happen to not react the normal way to nuts. So you got to have a part of your study that explains how did you account for these other possible factors. Right, because the nuts aren't the only reason why people die or live. Interestingly, if they were, nuts would be on everybody's mind all the time. Did you eat? I haven't eaten a nut yet. So, I don't know if we can see everything here. No, I guess not. Read the full article. No, we won't do that. But to me, obviously, it's way too obvious that I'm a big geek in general. I just love statistics, and it's true. But I know how they can be misused, misinterpreted. I'm always trying to be careful. Like the school does a lot of data analysis. The state is trying to define what student success is. And then they're trying to tie a college's funding based on how well it meets those. And personally, I don't know how you guys feel about it, but I think you guys need to have a little more responsibility for your own success. Now, colleges need to set things up for you to succeed. But I'm a little worried about how they're going to measure it and what they're going to measure. And if we happen to get a bunch of students who need more help and we're not getting funding, and then they're going to cut more funding because we didn't have enough students succeed. It's crazy to me. So you always try to push back a little bit against incorrect data usage. Okay. But that's why I love this course. If you stick with it, I'm hoping you guys will get to the point where you're at least asking questions as to how did you come up with that? Did you do it the right way? And not just saying, oh, I'm going to change my life now based on that article. No, you've got to really make sure they did it the right way. Let's see, anything else interesting here? Effects of Medicaid on clinical outcomes, blah, blah, blah. Nothing else too interesting. Facebook use predicts declines in subjective well-being. That sounds about right. How many guys is Facebook headed out? I mean, it's not long ago we had MySpace, and then MySpace went. All right, some people still use MySpace. I'm not dissing on you at all. Whatever you want to use, it's fine. But is everybody on Facebook nowadays? Is that true? Everybody? Yeah, I'm going to delete mine. I don't want to be on Facebook anymore, but I will. All right. Okay. As long as I got this up here real quick, I just want to remind you guys. It's really cool. A lot of you guys have already done this, but just to remind you, and I'll probably shoot out an email reminder too. Don't forget to do these 2 surveys, right? So I think about 23 of you guys have already done it. So that's cool. Okay. So coming back to section 1.4. Section 1.4, a part of section 1.4 is going to be that did they come up with a conclusion that makes sense? Or is there some alternate conclusion that you can give? That's part of it, right? So like coming up with a better conclusion than cell phone masts cause people to give birth, right? But there's also graphs that you can make that are bad. Does anybody know what the main bad thing is to watch out for when you make a graph? What's the worst thing that people do all the time when they're creating a graph? Do you know?
Mix up the axes.
All right, well, that's one thing, mix up the axes. But that's actually not horrible. It still shows the relationship, because kind of doing this is just completely arbitrary. You can turn it around and still do some stuff with it. Yeah.
Like the scaling, the height scaling.
Exactly. And did you have a different thing to scale?
I was just going to say, forget to say what the title's about.
All right, cool. You got to tell me what the hell it's about. But even that I could kind of tease out if you have at least it's labeled in units. But if you're scaling stuff, so I've taught physics in the past, and we do experiments, and they do measurements. And then they're supposed to get some, if it's decelerate, if you drop something, it should be accelerating. So you should get actually a nice parabolic curve like that. But if they graph it like this, 1 second, 2 second, 3 second, 4 second, that looks nice. 5, 6, 12, 17, 40. And they're like, oh, Mr. Waller, I got a straight line. Your theory is crap. Right? Now, of course, right there, that's really crazy. This is the main thing to watch out for, really. I mean, a title is good. You need a title. Units are good. I don't know what the hell units are. These seconds or minutes or what is this? But if your scale is screwed, you can't save that. You have to just start over again. You're seeing something you should not be seeing. There should be. If I wrote a scale that was independent of the numbers I ended up with, I should end up with a nice parabola. It should be increasing faster the later it goes. So be real careful. We will be creating a few graphs in here. Be real careful about your scale. But another way that's used to mislead people is if I had a graph showing men and women and income, and I had something like this. Let's see. I don't know, Jeff, what you got? 54. Why not? And this is in like thousands. Okay. So, obviously, we all know that there's still a disparity between what women are paid and what men are paid for the same amount of work. So we all know that there's a disparity. But that's why what really frustrates me is if you really believe in something, you want to be completely honest about what it is. The minute you do something that overstates it, then your whole case can be ignored. And you're like, no, it's still a case. It's still, there's something wrong. So here, it looks like there's this huge gap. But what's wrong? The scale isn't necessarily off. The scale here would be like, what would it be? That would be 51. But in what way is the scale off? Be more specific.
The whole thing. They're not showing the whole thing.
Not showing the whole thing, meaning they
Didn't start at 0.
didn't start at 0. If they would have started at 0, then these would have been a lot closer together, right? If I start at 0, if I redo this graph, I start at 0, and I want to get to 54,000. Somebody give me a decent scale to use for that.
10,000.
10. Okay, good. So 10, 20, 30, 40, 50, 60. So here's men, here's women. So men would go to 54,000, and women would go to 48,000. So that is still a difference, but it's not overstating the problem, right? And that's what really sucks to me is when people, I feel strongly about something, and somebody fudges the data a little bit just to make this case stronger. I'm like, the minute somebody sees that, the whole thing is gone. It's like, we can't trust you at all. There's no need to do that when in reality there is a disparity. So in the chapter, in this section, they're going to give you some graphs, and they're going to say, can you redo the graph to make it more accurate, to make it more honest? Okay, so this section should not be difficult, right? This section shouldn't be difficult. It's my hope, because most of it should be some common sense stuff. Another part of this section, let's see here. You know, there's little things like if you saw a study that was funded by, there's actually a problem here, funded by a chocolate company. And it was trying to show that chocolate is actually good for you. But it's funded by Mars, right? The Mars company that makes all these candy bars and stuff. What would you do with that data? What would you think about that study?
Biased.
Yeah, it's probably biased. Maybe it's not. Maybe it's completely not biased, but I have to assume it is. Because it was funded. It's sort of like, in politics, government wants to investigate itself. You got to love when it does that. Right? So we'll set up a task force made up of people from us that will investigate ourselves, and then we'll report to you. No, we need an outside agency. Otherwise, we can't trust any of what you found, right? But it still happens all the time. We'll tell you how well we're doing. No problem. Okay. Just a couple of specific examples real quick. In case you don't have the book yet. Uh-oh. Is it there somewhere? No, okay. Oh, yeah. All right. So it's probably... Oh, this is so cool, too. All right. That's for later. All right. Sorry, I'm geeking out. They got all these cool controls up there. So real quick, just to give you a couple examples of what this section is going to be like. Number 5. So number 5 says, based on a study showing that college graduates tend to live longer than those who don't graduate from college, a researcher concludes that studying caused people to live longer. So if you study, you will live longer. That's their conclusion. Now what's a better conclusion? A correct answer to any of these will not be, yeah, it sounds okay. These are all somehow not quite right. There's got to be a better conclusion. So what's a better conclusion for that?
People with a better education get better health insurance and will live longer.
I gotcha. It's changed a little bit now, hopefully someday if they get the website all working, but definitely if you have better income from getting a better job because you have a higher degree, then you should get better health care. Okay, right? That sounds plausible, so that would be a completely good answer for that.
People who do not graduate tend to have jobs that are more physically forced.
I like it. So that's the other side of it. If you don't get a high degree, then very often you might have to take something that's a little more hazardous to your health. You're up there on the 89th floor of this building you're building. You get a little imbalance, and then you're gone. So that would certainly cause the death rate, the longevity to go down for that group. Does that make sense? So those are two that's possible. I've seen others that were perfectly fine. So there's more than one answer to these things. It's just the conclusion they give just shouldn't make sense. Come up with a better conclusion. Then there's problems like this. Let's see. Number 13. In an ABC poll, 186,000 viewers each paid 50 cents to call a 900 telephone number with their opinion about keeping the UN, I think they mean the U.S. and the UN. The results showed that 67% of those who called were in favor. Interpret the results by identifying what we can conclude about the way the general population... Okay, so can we say anything based on that study about the general population of Americans? Why not? They talked to 186,000 freaking people.
So all those people watch that show?
Good. One thing is they all have to be people that watched ABC Nightline. So what's wrong with that sample right off the bat, specifically?
It's biased to that group of people that watch that show.
Good. I like it.
It's not random.
It's not random. Why?
Not everyone has an equal.
Not everybody has a chance. Because if I don't watch the damn show, I don't see the number, I can't call. And not only if I watch the show, what else? Okay, I like it. So somebody used the word I'm talking about, voluntary. It's a voluntary response sample. You actually have to volunteer to respond. And the people that don't, has anybody ever called you at home and asked you a question? You always see them. Have you ever been called to say, what do you think about this candidate? You've been called about something like that? I haven't been yet, and I'm a stats teacher. I'm like, come on. Yeah, that's what they don't want to call. But if you decline to comment, the people that decline to comment have characteristics that bind them together versus the people that do want to comment. Therefore, your results will be skewed. They will only describe this kind of person. They will not describe the entire population. So when you hear that data has been skewed somehow, for some reason it's only targeting not your whole population, but a subset of that population. It's not good. You guys with me? Okay. So if you want to say something about the entire United States and you only pick people that live in Wyoming, you're not talking about the whole U.S., you're talking about Wyoming, right? There's maybe... So we can't say a damn thing about the general population from the study. I don't know. I can only talk about the group of people that have the characteristics that shared with the people that actually called in. That's it. Okay. All right. That's good for getting a feel for what that homework is going to be like. Okay. So hopefully you've started Chapter 1 homework. Everybody has access to Chapter 1, even if you don't have a book yet. Remember, because you can go to the website. The link for Chapter 1 is there. So you can access all the homework and stuff. Get the book from the library. You can get the book from the study center. It's insane. Right? And I just found out the other day that there are nifty... I knew that Pirate Bay existed. Have you guys heard of the Pirate Bay? It was improved for a while. I'm not sure where it is. It was on a boat for a while. I don't know what the hell. They're trying to be true pirates. I don't know. But you could download illegally like movies and stuff. You know, it sounds like Napster a long time ago when people got in trouble for downloading music. Right? I've just found out 2 days ago that there's something similar for textbooks. Yeah, okay. I figured Pirate Bay must, I don't know. Pirate Bay must have a section for textbooks too, but I knew it was for movies and stuff. That's all I'll say about that. It's out there. You got to be careful. It's illegal, so it's probably not the greatest idea. But I just want to say, it's amazing what's available now. The fact that it's illegal is makes it difficult to use without some risk. But it's crazy what's you can do with this nowadays. And I'm sure that the publishers are probably actively hunting them down. You could have a really weird TV show about publishers hunting down people pirating textbooks. Okay, so we actually just finished chapter 1. Last time that was the only section we didn't do, was section 1.4, the critical thinking section. So today we're going to get into some of our first little baby steps into really analyzing some data. And since I only had 23 people so far, and that's fine because you have until Monday, I decided what might be interesting, I've never done this, is to use some data from a previous class. I started looking at ages, but what's wrong? What do you think might be wrong with me using the ages of my class to illustrate how to make graphs and stuff? What might be wrong with that? What might be kind of weird about our ages?
Most of the people going to school are younger.
Exactly. So we'll basically almost guaranteed to get a graph, and in fact, every time I do this, it comes out this way, which is not a surprise at all. I'll get a graph where I'll have like 18 to 20 to 22, and I'll have wow, and then it'll disappear, and there'll be one little dude way out here, right? And if I put myself on there, I'll be out there with that little dude, I don't know, right? But I mean, that's very often it's even worse than this. I mean, I think last semester I had something like it just immediately disappeared. It was everybody was just fresh out of high school, which is fine, but it's not good to see. It's not good to introduce a topic. So what I have here are all the Quiz 1 grades from my class last spring. So the Quiz 1 that you will eventually take, this is the grades that they made. So what I want to do is I want to end up with a picture, and let me kind of show you the difference between this and that. Anybody know what this kind of picture is called? What this kind of graph is called? Bar graph. I love it. Bar graph, because mathematicians are very creative. They said there's bars. It's called bar graph. So this is a bar graph. And normally bar graphs are used for qualitative data. Of course, qualitative is what kind of data? So it's definitely not
Names again.
Yeah, it's names, so it's definitely not numbers. So it's not numerical. When I make something similar to this, but I'm using actual numbers, it's called a histogram. So it's basically the same idea, except because I have numbers. So for example, if I'm talking about ages, if I had a graph like this for age of students, so this is the number of students, this is their ages, and I had something like this here, what would these gaps represent to me? Now remember, we're talking about numbers, so this would be like, here's 18, 20, 22, 24, I don't know. So what am I telling people if I have gaps on my histogram? What do gaps really represent?
0.
Yeah, there's nobody there. So I don't want to have gaps unless I really mean there was nobody in this age group, right? So there should be, for a histogram, there should be no gaps. Okay, so that's one big note right there. Right? I don't have a list of that right now, but that's the first thing I just want to talk about. There should be no. That's the main difference between the look of a bar graph and the look of a histogram. Okay. This, I don't care if there's a space. There's nobody here. These are numbers. This is scale. There are numbers everywhere on the scale. So if I have a gap, it looks like I'm saying there's nobody there. Okay, maybe. So this is our. This is a bad histogram. This is what we really want to end up with. So if I'm talking about quiz grades, if I talk about quiz grades, what shape do you think it would have if it's a large enough sample? What shape do you think quiz grades would have? Yeah, it should be kind of bell curved, right? Now very often I don't get bell curves, especially for quizzes. Tests are a lot closer to bell curves. And why do bell curves? Bell curves are often called a normal distribution. Because it's kind of like what happens naturally. So if I plot heights of boys at age 7, I'd expect most of them to be a certain height. But of course, some of them are going to be shorter than that, and some of them are going to be taller than that. But most of them should be right around a certain height, and you get that nice bell curve, that nice, what's called a normal curve. You guys kind of with me? Because that's what happens normally. That's what I could expect. I don't expect, if I saw this, I'm like, what the hell happened there? You guys live near chemical plants, and I don't know what's happening. Okay, that's not normal. So what I expect for quiz grades might be bell curve shape, roughly, right? So that's the kind of shape I expect. And see how there's no gaps, so I'm not saying that there is anybody that you're missing in the middle. I don't want to make somebody feel that I missed data, or I'm saying there's nobody there. Okay, so that's our goal for a histogram. Okay. So let me give you a little hint about doing this homework in Chapter 2. Section 2.2 and Section 2.3. Do them sort of together. Because 2.3 is going to say, okay, take what you did in 2.2 and now do this other thing with it. So it'll so suck if you turn 2.2 in. And you're like, let me do 2.3. Oh, shit. He's got all my data. Right? So do 2.2, 2.3 together and turn them both in together. That'll make it easier for me to grade. Dear God. So do them, sort of together. Because 2.3 refers back to 2.2. 2.2 is setting up the tables of data. Right, so this is my end result. But to get there, I actually have to figure out what do the heights of these bars really represent. So this is like 60 to 70 to 80. Oh crap, my scale is weird. Somebody made 120. Oh, well, 40 to 50 to 60 to 70 to 80 to 90 to 100. There you go. Yeah. What do the heights represent? The number of people that were in each, what's called a class. So this here would be called a class. Right? So any region, any interval from 60 to 70, that's a class. The height of the bars, the number of people in a class, sounds really stupid simplistic, right? What class and how many? But it's a beautiful visualization, very quick way to visualize the data. How is it spread out? And that's one reason why we call this table, we call it a distribution. To be more specific, we call it a frequency. Get it in there. Wow, Jeff, you write bad, but not that bad. Come on. Ooh. Frequency distribution. Right? So it's a frequency distribution. So the reason we call it that is, if I count how many people made between a 60 and a 70, I'm seeing how frequently did somebody's grade show up in there. So that's the frequency, and I'm seeing how it's distributed across all possible grades, across all the grades I saw. How is it distributed? So it's called a frequency distribution. Crazy. So Section 2.2 is all about setting those up. Section 2.3 is all about setting this picture up based off of your table. Okay, so we're going to try to, based off of this data, we're going to make the table and then see if we can make the histogram. And then next time we meet, hopefully I'll have all the data for most of you guys, and I'll have you make a histogram for some aspects of the data that you put into the survey, like your heights or your age in months or something. So the first thing we want to focus on, so this is section 2.2 kind of stuff here. We're making a frequency distribution. We want to focus on the classes, because if I can get those set up, I just have to go count how many things showed up in that class. So how the hell do I set up a class? So 1, set setting up classes. So tell me this. The lowest class should definitely start around where? 40, or maybe 40. I could start right at 45. I have to start somewhere below 45, so the 45 has a home, right? Has a place to go. Does that make sense? Normally, we want to go ahead and start at the number itself, but if you're like using 10 as your class width, then you want to go 40, 50, 56. I understand that. That's fine. But we normally could start at 45. Now, here's the thing. If I know, in this case, how far do I have to go from 45? How far up do I have to go? 98. And here's the little thing to consider. The number of classes allowed is 5 to, the book says 12, but we're not going to have a data set so big that we should use 12 classes, to be honest. So 5 to 10. So I don't want to make this become busy work. Busy work would be if I give you 200 data points and say, make a history. Oh, yeah, that's busy work. Right? But I need it to be a decent size sample. You know, you want to use 5 classes up to 10 classes. The smaller your sample, the fewer classes you want to use. Does that make sense? Because if I use too many classes, if I use 10 classes and I only have, like 15 data points, then it's like one can go in each with a couple. It's just not showing me enough distribution. I made it too fine of a resolution. I don't know if that makes sense. So the lower your sample size, the less classes you want to use. To be honest, there's actually an equation based on the logarithm of the sample size to figure out exactly, but screw that. There's no need for that. Just the lower the sample size, you use smaller classes, the bigger, you use more classes. Right? That'll get us through. So this is for bigger class size. So we have not a big sample, but it's not crazy small either. So how many classes do you want to use? All right, you 5 or 6. I think I heard a few more 6s. I don't really care. We'll use 6 classes for this example. Why not? Okay, so what I really just did was figure out how many rectangles I want on my picture. You with me? There'll be 6 rectangles sitting on my picture, 6 bars on my histogram. So here's the next thing I got to do. Now let me see if you guys. It's always good to have a visual in your mind. Let's see. If that wall there started at the 45 mark and went to the 98 mark, and I want to put, I want to have 6 wood panels to put on there. For some reason, I love wood paneling. Just can't help it. So I want to put 6 wood panels. So they can change the size, but I want 6 because I'm just weird that way. Can somebody come up with the math that would tell me how wide they'd have to be? I don't want to have a little bit of brick showing, which mathematically would mean I don't want to leave any of my data out. So if I don't make my rectangles big enough, I might end up with the last one being there and leaving some out. Does that make sense? It's perfectly fine to overcover as long as you cover. You guys semi with me? Okay, so now think about it physically, not mathematically, just physically. If I know how far I've got to go, how far do I have to go? To cover, how far do I have to go?
53.
Yeah, 98 minus 45, so I've got to go 53. We call that the range. Right, so it's a little earlier. I don't think the book uses that word yet, but I can't remember. But that's what it is. What the hell? It's the range. It's how far my data ranges. So it only makes sense. It's kind of nice. High minus low. So that's how far I've got to go. And I know I want to use 6 rectangles. How wide does each one have to be? Well, I've got a distance that I have to do what with for these rectangles? What mathematically? What do I... Divide it. I love it. You got to divide the distance you have with 6 rectangles. So you just take, so to get the width, to get the class width, it's going to be range divided by number of classes. So I'll tell you this right now. On a test or a quiz about histograms, I'll say, come up with your own class width, show me how you came up with it. And I always have people say, well, I just thought 10 would work really well, and sure enough it did. No, that's crap. I want to see this. This is exactly what I want to see. You get to pick your classes, how many classes you want to use. The range you calculate, and each divide the two. So what do we get here? We got 53 divided by 6. I think it's 8.83. 3333. That's not quite 9, right? Because 6 times 9 is 54. But who cares? It's fine. You can round up, thank God. It's 8. I'm pretty sure it's 8.83 forever, right? I know math. That's it. That's all I can show off with. Anytime, dear God, please, do not use 8.83. Round up to the next whole number. All right? So I'm going to round this up to 9. So all of my rectangles will now be 9 wide. Okay, how are we doing so far? Okay. This math is not bad, it's just new. We're not used to doing stuff like this, but it's not difficult math. Okay. So I know I want to know. I'm going to show you 2 different ways of doing this. There's the textbook method, this textbook, and there's the method that I was taught a million years ago. And I personally like that way better, not just because it was the first way I was taught. I'm going to show you both, because I know as a student you want to have some backup with the book very often, right? But if you like the other way better, you can certainly do it the other way that I show you. So I'm going to show you the textbook way first. So on the side here, I want to kind of draw an example of our goal. We know we're going to start at 45. We know we're going to include 98. We might not necessarily stop at 98 because we rounded this up. We're going to go a little further, more than likely. Does that make sense? That's cool. We just want to make sure everybody's got a home. If my class width we figured out was, where'd it go, 9. And I start, and my first class is 45. What should my next class start at? 54. Okay, cool. 54. All right, now that's not crazy difficult, right? So I got 45, and then I got 54. But now tell me what number goes here. The first class ends where? Yeah, it definitely cannot end at 54, or then where the hell do you put 54? In both? And then it looks like you have more data than you got. So this has got to be 53. So then people will say, it looks like that's a width of 8. Right? But of course, if you count from 45 to 53, that's 9 numbers, if you really want to get down to it. I'll show you a better reason why the width still makes sense. But is that cool? That's what I always do. Put the number you want to start, add the class width to it. That's where the next class should start. And then that's going to be 1 less than that. And now you just start adding class widths to both. Right? The next ending point should be 9 past that one. So add 9 there, add 9 there. Or you just realize you just add 8 in between here, right? Either way you want to look at it. Add 9, add 9, add 9, add 9, add 9, add 9. So we did end at 8. Good. How we doing? Not too bad. Now you see why you do not want to use 8.83. Dear God, you need to add 8.83. No. Don't do that to yourself. Please don't do that to yourself. Don't be mean to yourself. That's my job. So these are the classes. I don't want to mess this up. I want to put, this is exactly the way it's going to look when you do it from the book. Then you're going to put the frequency, and this is just a tally. You just start tallying how many things actually show up in the class. So how many people made between a 45 and a 53? And look at me, I was so nice, I put it in order. So one thing we're going to learn next time. Next time I'm going to have the calculator Bible handout. It's up on the website too. And we're going to start using our graphing calculator. So I'm going to bring some for anybody who just doesn't have one yet. On those kind of days, if you have the Android app, I think I told you right about that. You can certainly use your phone in class, just not on the quiz or a test. We'll learn how to sort data in the calculator because I don't want to sort 100 data points at my desk. Screw that. Calculator costs a lot of money. Should be able to do it. So we got 3, obviously. Is that cool? 45, 48, 50. They all fit here. So there's 3. All right, let's keep going. 54 to 62. 7. Cool. So, right, there's 7 grades that fit between 54 and 62. One year I had a student that just had all 8s here. He just said, well, there's 8 grades that fit. No. It's how many actual grades that I see fit in those classes, right? Otherwise, every histogram would look the same. That'd be kind of crazy. What about 63 to 71? 1, 2, 3, 4, 5, 6, 7, 8, 9. I like it. 72 to 80. 11. Man, I don't trust you guys at all. 81 to 89. I'll trust you. How's your tongue to lie? Yeah, 81 to 89 would be 11. 8, 9, 10, 11. 12, right? 81 to 89. Oh, those 2 also. So 14. So 1, 2, 10, 14. And then 90, 98, the last 6. Cool. And what's one quick check you can make? How many total grades are there? 8 is 1, 2, 3, 4, 5, 6. 50, I think, right?
Yeah.
That's nice. I didn't do that on purpose, but that will help us when we make percentages. So what should these, of course, add up to be? 50. And do they? 10, 20, 30, 40, 50. Yes. Sweet. So check that real quick. And the reason people hate statistics, and I cannot blame you for this, is because it's so easy to make a little stupid mistake. So if you count right there and you get 49, I completely understand. You go, oh shit, what did I miss? All right, you got to go back through again and do it. And that's the bean counting kind of tedious thing that you just have to do sometimes for this kind of thing. You with me? So just be careful. Just make sure you make that check. Right? If you get running out of time and you get 49, you're like, I know I missed one, but I just don't have time, and you just finish it out, and that's fine. I'll give you partial credit for that, for at least noticing that. How would I make the percentage? And the way we call the percentage in statistics is relative frequency. And the reason we call it that is because it's relative to how many things there are. So out of 50, how many were in there? 3 out of 50, that's the percentage. So we call it relative frequency. Okay. How you guys doing? You all right? Okay, I get fewer and fewer of you saying you're okay. All right. So the reason this should be easy is because it's out of 50. So to make that into percentage, you would just double it to be out of 100, right? So 3 ends up being 6%. Is that cool? 3 out of 50 is 6 out of 100, so 6%, 14%, 18%, 20. It won't always be that nice, but you got calculators, so suck it up. Just looking at that, and even just looking at these, does it look like it's going to be normal? Does it look like it's going to be a bell curve? What's kind of wrong with this, just to give an answer away, for it to be a bell curve? Where should the highest number be? In the middle. So this looks like it goes up, 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 down. It should go up and then down. That's what it should do. But it goes up and down. So that's not quite bell curve. It's almost a bell curve, not quite. You guys with me? It's skewed in a decent direction from a student's perspective. It's skewed towards B's. And then there were a few people who got an A, right? It's better than being skewed towards D's, right? Okay. So this is exactly what section 2.2 is going to ask from you. It's going to give you a list of data. There's also data sets in the back of the book it might refer to. So you can look at the back of the book and you just do the data just like we did up here. You make the table, that's section 2.2. Section 2.3 will say, look back at what you did on this problem. Now set up the histogram. Oh, before I get too far away, I need to hire a cameraman. Before I get too far away from that, real quick, just to show you, I promised you 2 ways to do this. I really hate this. Actually, let me do this. I'm going to show you really why this way is not the best, and then I'll show you the other way to do it. And when you really see why this way is not the best is when you start to make the histogram. And let me be more specific. I want us to make a frequency histogram, which just means what? What do you think that means? I should use these numbers, not these. So if I wanted these numbers to be used, I'd say make a relative frequency histogram, right? So believe it or not, I will take points off if you don't read carefully. If I ask for one, make that one. Don't make the other one. All right, use the right numbers. What should go along this axis here? Yeah, the numbers, the frequency. So the frequency should go here. And of course, what's going to go along this axis here? Great. So the quiz 1 grades. Cool. I like it. Now I'm about to make a mistake, so maybe just watch for a second, because then we'll go back and correct it. If I just start writing down what I got over there, I got 45. And don't worry about this. You got a little, it's okay to not start this necessarily at 0, because there's just a whole bunch of places where you don't have data. Nobody made a 20. So you don't have to go way over here to start at 45. You just have a little like heartbeat thing that means break. There's a break I jumped over where it's empty, and I can start at 45. So that's not a problem. Is that cool? Please, dear God, don't start at 0 and then get all the way over here, and then your histogram's way over there at the edge of your paper. I can barely fit it. No, don't do that. So if I start doing this 53, what comes next? That, that's, and then it looks like I have a gap. I'm not supposed to have any gaps. So how do I take care of that? What you officially have to do, these are class limits. These are called class limits. And what you officially have to use is called class boundaries. So like the difference between the limit of me and my boundary, my personal boundary. And step off, you're getting in my boundary, right? So the boundaries would be, in this case, 44.5 to 53.5. You guys see that? It's my limit and then my boundary, right? So it's the boundaries are just a half point off from the top and bottom. And why does that work with the problem we have here? We had a stupid little gap between 53 and 54, but where does this go? 53.5. Now these match up. There won't be a gap. You guys kind of with me? So the book explains all of that. So I want to show you this method because it's the method the book uses. So we're going to finish this histogram, and then I'll show you the method that I personally use. And then you can pick which one you want. I'm not going to like you better just because you use the one I use. I don't care. You just pick whichever one makes more sense. So we have to go back then and actually start at 44.5. 53.5. The nice thing is, remember what the class width was? 9. So I just keep adding 9 now. 60. I don't have to look back there. 62.5, 71.5, 80.5, 89.5, 98.5. Cool. And that captures everybody. And what kind of scale? Let me let you guys catch up. This This isn't that bad, right? Don't let this be bad, because it gets a little bit worse. What kind of scale do I want to use here? I want to get up to 14, so what kind of scale might I want to use here? Yeah, I could use 2. I think I would use, we could use 2. Let's see. 2, 4, 6, 8, 10, 12, 14. That sounds good. Coolness. And now you just start making your bars. You make them as tall as the number that showed up. So the first bar would go up to what? 3. I love it. So that to 3. And then the next bar would go up to 7. And then up to 9. And then up to 11. And then 14. And then finally, just move that over, 6. It's a very quick visual of the class grades. Right? I can see the shape of it. It's not normally distributed. It's skewed in one direction. It's skewed in a good direction, so I'm happy. Right? I don't require a normal distribution. Some people freak out. Everything's got to be normal. So what if you have a really good class and they all make A's? It doesn't mean you've done something wrong. It means enjoy that. Right? You try to force them into their F's. The lowest A's are F's now. It's crazy. So if I would ask for a relative frequency, you would have just used the percentages. What would have changed about this image, the shape, if I would have used relative frequency instead? Nothing would have changed. Nothing would have changed. It would have just been percentages here. The shape would not have changed, right? Okay, maybe. So here is the alternate way to do the classes. If you are like me and think that that's a little too much crap to keep track of. I'm going to erase this here. So these are my alternate classes. And then everything else will be the same. Once you set the classes up, you still count the numbers, and everything else is the same, except the scale will be so much easier to set up. The reason people don't like this alternate way of doing it is because they have problems with inequality symbols, and I have to use the letter X in there for some algebra stuff, and people are like, I don't want to do that shit. But I hate the ambiguity here. There's like this imaginary bound. I don't like that, personally. I'm not saying there's something necessarily horribly wrong with it. I just don't like it. So what we do here, this is the beautiful thing about my way. 45 plus 9 is 54. Yay, you can see exactly the width there. But then the next class has to start at 54, right? So what you say is, you say like that. So where would 54 go? Which class would 54 go into? The second one, because the first one is less than 54. The second one includes 54, right? So this is why people don't like that. Part of me is like, you've gone through algebra, you shouldn't be scared of it. Damn it. But you do have this way if you want to. The only trick there is being okay with the inequality symbols and the variable. But the beautiful thing is, my class limits and my class boundaries are the same. So when I go to make my scale would be 45, 54, 63. Oh, so much better. And there's a whole range of problems that come in when you have decimal data. Where would 53.2 go? I haven't set these up correctly. I have to actually add little decimal places for that. Here, where would 53.2 go? The first one, because it's less than 15. I don't have to. There's no ambiguity, no matter how many decimals your data has. Okay, maybe. Okay, hopefully nobody's out there going, I completely didn't get any of that. So you get to pick whichever way makes more sense. Yeah.
So on the test, you put like those symbols.
If you want to use this method. You never have to do any of this if you don't want to. You can certainly just go ahead and do just like the book does.
In histogram, we have to put the 0.5 otherwise.
If you do it this way, you have to use the boundaries. Exactly. Cool. So it's totally up to you which way you want to do it. And I'm not going to grade you differently based on your way. You just better do it right. Cool. So I'll tell you what, I always forget that I have a little more time now, because statistics used to be 3 credits the last time I taught it. And then I'm one of the ones who put the proposal together to make it 4 units. So I don't know how you feel about that, but no matter which way you feel about that, I'm happy, because we can finally fit stuff in. So I have more time than I ever think I do. So what I want you to do is I want you guys, let me find something for you real quick. It would be nice if I could find some data that's in order. I'll tell you what, I'm going to make up a list of data and put it on the board, and I want you guys to do the table and the histogram for it. Okay? So everybody got what they want here? Let me leave that up there for a visual. Take this off of here. So I'm going to put it in order today, and the next time we're going to do how the calculator can do that for us for a large set of data. I don't want to do that by hand. So these are, I don't know what they are. Ages of people in mall. So this will be in order. Here we go. That's enough. Oh, let me, just so you don't freak out over something. Sure. Okay. So I got 1, 2. I don't know if I counted correctly. I think I got about 26. So do everything we just did. Do the 2-2 stuff, make the table, the frequency distribution, and make a relative. Just turn them into percentages. And then go ahead and make, let's do a relative frequency histogram. Relative frequency distribution and histogram. Call me over if you need some help.
this is statistics, sorry, too. So we want to